that might reduce the opportunity for their traffickers to exploit them.
Dame Sarah Thornton, thank you.
19 minutes to 9 now. This week, Cambridge has confirmed its status as one of the world's leading cities for scientific research after Cancer Research UK announced the largest single grant ever awarded by the charity outside the capital, £173 million in its Cambridge Institute. The significant funding commitment will enable world-class discovery science, unlocking new insights into how cancers develop, grow and spread, as well as examining how the immune system can be harnessed to combat the disease. With more, here's our science reporter, Tom Fielden.
The applicator with the capsule and string will go into the back of the mouth. I'll release the capsule and string and then take the applicator out. You'll then need to take nice big gulps of water to help get the capsule down.
OK. I'm at the NIJR's clinical research facility at Cambridge's Addenbrooke's Hospital, where, in what feels like a nod to the best practice of the 17th century, I'm about to perform an experiment on myself.
Wash my hands.
But unlike those pioneers of the early scientific method, I have clinical research nurse Manju Suni on hand to put me through my paces, administering a capsule sponge test for esophageal cancer.
You want to take nice big gulps of water. Just concentrate on the swallowing. Does it feel like there's anything stuck
No, it just
anywhere?
feels a bit strange having a piece of string in the back of my throat. But other than that, it feels fine.
So you swallow the capsule with some water and the capsule will dissolve.
The capsule sponge test, a pill on a string that dissolves in your stomach, releasing a sponge that can then be drawn back up through your throat, gathering cells from the lining of your esophagus, is the brainchild of Rebecca Fitzgerald, the Professor of Cancer Prevention at Cambridge University and Director of the Early Cancer Institute.
And you'll collect cells from the whole length of the esophagus.
It's a brilliantly simple, cheap and easy to administer idea that promises to revolutionise the diagnosis of esophageal cancer. But it also encapsulates a profound shift in the focus of cancer treatment away from the later, more intractable stages of the disease and towards the earliest indicators that a problem may be beginning to develop.
This is a really exciting time for improving outcomes for cancer. It's true for most cancers that they take a long time to develop. And usually, by the time we know it, the situation is going to be just harder to solve. So if you can wind that back, we can be more proactive, tests are simpler, the treatment is going to be simpler, and the outcomes are better. So I am excited we're on the cusp of a new chapter for cancer.
It's the sort of new chapter Cambridge has a habit of writing, from the original discovery of DNA structure in the 1950s through the development of monoclonal antibodies in the 80s, next-generation genome sequencing, and more recently, the development of drugs that target cellular repair mechanisms, so-called PARP inhibitors, like olaparib.
Cancer cells live life fast and loose and basically disregard certain pathways that are not actually essential, but maybe allow them to proliferate and get more mutations.
Professor Sir Steve Jackson, whose great insight was to realise that cancer's buccaneering, shortcut-taking success was also its Achilles heel.
But as a consequence, most cancers, in fact, have vulnerabilities. They've become addicted to living in this type of way, and they've thrown away some of the safeguards that normal cells will have. And so this drug, olaparib, and hopefully in the future other drugs targeting similar opportunities, are basically taking advantage of a weakness of cancers. They may be proliferating faster, they may be disregarding the normal cues, but that provides a vulnerability. They've thrown away a safety mechanism.
Steve Jackson's lab sits at the heart of the Cambridge Biomedical Campus, the biggest centre for clinical research, medical science and computational biology anywhere in Europe, that's sprung up around the Addenbrooke's Hospital site and world-famous research institutes like the MRC's Laboratory of Molecular Biology. And it is a hive of construction activity. Recent additions include AstraZeneca's impressive Discovery Centre. Where I'm standing right now, work is due to start on the new Cambridge Cancer Research Hospital next year. There's even a new South Cambridge railway station taking shape on the edge of the campus, due to open in 2025.
So this is a scan of a patient's brain.
A striking example of how the disparate elements of that life sciences ecosystem can come together to generate more than the sum of its parts is Osiris, a cloud-based AI technology that's dramatically cut the waiting times for radiotherapy treatments at Addenbrooke's Hospital.
And the black hole that you see is literally a hole where most of the tumour has been removed.
Raj Jenner is the first professor of AI radiology.
What's important is the Department of Mathematics is 5 minutes that way, the hospital's 15 minutes that way, and the Department of Computer Science is across the way. That's the real unique thing, is that we bring people here to the biomedical campus, engineers, mathematicians, physicists, and it's the ability to draw on that I think is really, really unique.
If you open your mouth wide for me, say, well done. Perfect, well done.
Oh, wow. That comes out very quick.
Yeah, we try and do it quick.
And hopefully that'll mean more cancers caught at an earlier stage and simpler and less intrusive treatments.
People say it looks a bit like a Brillo pad.
It looks just like a Brillo bag.
But yeah, so we'll send this off for testing, and then whatever it comes back with, we'll get back to you.
And that was Tom Fielden reporting from Cambridge. Brings us to 13 minutes to 9. Joe Biden is in Berlin today. Keir Starmer, other European leaders as well. Biden is, of course, still president, but with Donald Trump potentially in